Hello and welcome to Education at SSBJ online video tutorial. In the previous video lessons, we have learnt how to represent any vibrations in terms of graph. Maybe it is disturbance in the pendulum movement, or maybe a disturbance in the water. Every vibration can be represented on graph. We have seen how the pendulum swing can be put in terms of graph. As the pendulum moves to and fro, you can see on the screen the graph moves on, and as the pendulum swings, you get a kind of graph on the screen. This is same with every vibrating object. Do you know, nowadays you can even represent the vibration of your vocal cord in terms of graph. Right now in front of you, what I speak is coming onto your screen. If I bring down my volume, you can observe the pattern of graphs, and when I raise my volume, you can see how the graphical representation change. This is how every vibration can be put in terms of graph. We have also seen meaning of time period. Time taken for one oscillation or vibration is time period, right? We have done few calculations on finding time period. In the animation shown here, it takes how much of time to complete one vibration? 7 seconds. So time period of this vibrating body is 7 seconds. Finding time period will be more easier when you take a time for 10 vibrations or 10 oscillations, because measuring time for one oscillation or vibration is a bit difficult. So it is better to count for 10 vibrations and then divide it by 10, you get time for one oscillation. We have also learned that all the extreme positions of a wave or any vibrating body, such as a point which is shown on your screen, are called as or referred as trough, and the extreme positions on other side, which again is there on your screen, is referred as crest. So therefore, a wave will be consisting of trough as well as crest. Here is a wave in front of you, and you have already studied that frequency is number of waves per second or number of vibrations per second. Suppose if these waves are formed within a period of 3 seconds, what will be the frequency of this vibration? So we know what is one wave. One wave is from initial position to crest and then to trough and back to initial position, right? So this is one way. And recall, what is the definition of frequency? Number of waves in 1 second. And what you see on the screen are number of waves in 3 seconds. So you can count how many waves are there. What is represented on the screen is one wave, and then such 2 more waves are there in front of that one wave, and totally 3 waves are there. Right. And now you can tell me 3 waves are formed in 3 seconds, or 3 seconds, 3 waves, therefore 1 second, 1 wave will form. Is it not? So 1 hertz or 1 waves per second is a frequency of this pattern. Every vibrating body will have a frequency, including human beings, birds, any living beings, or anything which is vibrating. What is my frequency right at present? You can see right now on the screen. It varies. You can change your voice, do a bit of modulation, and your frequency changes. Most of the singers are more expert in controlling their voice, and that's why they can sing better than us, right? So understand, you also have a particular frequency. So you are identified by particular range of frequency. Like how my frequency is shown on the screen, every vibration will have a frequency. Frequency is number of vibrations per second, and it is measured in hertz. Some objects or a medium vibrates faster, and then we say frequency of that medium is more, and some vibrates less. Shall we have a demonstration now? What I am holding in my hand is called tuning fork, and in the other hand I have a rubber cork. These two are the blades of the tuning fork. When I hit it on the rubber cork, these blades vibrate, but we don't see them vibrating. You can read that 341 is written there. It vibrates. But how do we know whether it vibrates or not? I'm going to bring it near a container there. You can listen to the sound. Yes, they are vibrating. How fast are they vibrating? Let us check one more tuning fork where number is written for 80. Yeah. Now, can we understand how fast they vibrate? Watch this very closely. What is the number written them? It's 480. And what does this mean? This means this tuning fork has a frequency 480 Hertz. But wait a minute. 480 Hertz? What does it mean? It means this particular tuning fork vibrates 480 times in 1 second. How many times? 480 times. So the number which is written on that is its frequency, 480 hertz, which means 480 times it vibrates in 1 second. Now look at this illustration. You are watching frequency of the voice on screen which is being played. We shall also see frequency of birds chirping. If you observe the frequency there on the screen, you see sometimes frequency of the birds chirping will go more than 2000 hertz, 2700, right? Frequency is not the loudness of the voice. Loudness is different. Frequency depends on vibrations in 1 second. You have seen in the previous illustration, bird chirping has more frequency, which means vibration pattern is faster. Whereas human voice have lesser vibration. But among the humans, children will have more frequency. As you grow, the frequency of the sound reduces. But the women comparatively has more frequency than men. Child, birds will have more frequency than men. A girl child will be having much more frequency than a male child. So what is that nature of a sound whenever there is a high frequency? You all know nature of the sound changes. Male sound is different than women's sound. And I said women sound has more frequency. And that quality of that sound which has higher frequency is called shrillness. That means baby girl, birds, women have more shrillness than men. Higher the shrillness, higher the frequency. Let me give a clear picture of what shrillness is, so that when you hear two sounds, you can immediately tell which is more shrilled voice. What you are watching on the screen is a sound pattern of my voice. Now I am going to change the frequency of this pattern manually, because software allows to change the frequency. So I stop the recording now. My recording is stopped and this is my voice. You can hear this voice now. I am playing it. Let me give a clear picture of what shrillness is, so that when you hear right? I have paused it. Now I'll select the wave pattern and then change the frequency. I'll slightly increase the frequency and look at the nature of my sound now.
Let me give a clear picture of what shrillness is, so that when you hear two sounds, you can immediately tell which is more shrilled voice.
Okay, now that previous voice you compare with this present voice, the quality of the nature of the voice is changed. The second type of voice was bit of like women type of voice, isn't it? And that nature is shrillness. I hope you have understood with this illustration. Now at this point, I am going to take up two simple questions straightway from your NCERT textbook. Why two? Because these two questions are related to what you have learned in this video tutorial, right? So the question is here in front of your screen: voice of which of the following is likely to have minimum frequency? You have option here: baby girl, baby boy, a man and woman. So what is asked here in this question is, we have to pick up the option which has minimum frequency, right? Now what we have learnt in this video, that among baby girl, right, and baby boy, man and woman, who has more frequency? Can you tell me? Just recall. And I will give you a hint. More frequency is more vibration. High frequency voice is more shrilled voice. Now tell me, whose voice is more shrilled? It has to be a baby girl. So baby girl has a very higher frequency among these options. And the next one may be baby boy. The third may be a woman, and fourth may be a man. This is what I have told is about more frequency. But the question is about minimum frequency. Obviously, it has to be a man, because comparatively women has more frequency than him, baby boy has much more, and then baby girl is the highest frequency. So minimum frequency option is a man. So the answer is man. Now second, again a simplest question. Shrillness of the sound is determined by what? So just now I have told, higher the frequency, higher the shrillness, right? So higher the frequency and higher the shrillness. So answer is, it's a frequency here, right? Well, we'll conclude here and see you in the next video tutorial. Till then, stay healthy, stay strong. Thank you.